Hello everyone, welcome to another video. In this video, what we are going to focus on is the cosine of an angle. So by definition, the cosine of an angle is equal to the adjacent length divided by the hypotenuse length, right? Now, one thing that you should know about the cosine, about the cosine ratio is that it applies only to right angle triangle, right? Now you should be able to label a right angle triangle in terms of hypotenuse, opposite, and adjacent given a working angle, right? For example, here I have a right angle triangle and my working angle here is theta. So if you draw a line all the way from theta going down to this side would be opposite to the angle theta, which is in question. So that means this side is opposite. Now, the hypotenuse is always the longest side, and it is always opposite to the 90 degrees angle. So that's how I know that this side here is the hypotenuse, which means that the adjacent side is always adjacent to the working angle because it helps to make, it is one arm of the working angle, right? So that's how we know that that's the adjacent. Okay, so what we know is that the cosine of an angle in a right angle triangle is the ratio of the adjacent side to the hypotenuse side. Note that the cosine of an angle ratio is used to calculate the length of an unknown side in a right angle triangle and the measure of an unknown angle in a right angle triangle. Okay? So what we're going to focus on in this video specifically is how we use the cosine of an angle ratio to calculate the unknown side in a given right angle triangle. Okay, so here we're given a problem. And the problem that we have here is this right angle triangle. We have an angle inside of the right angle triangle. And we are given one length of the right angle triangle, and we're asked to calculate another length. Now, the best approach to this question is to label the triangle based on the information that is given. So we know that the longest side is the hypotenuse, and that side is always opposite to the 90 degrees angle. So this is our 90 degrees angle here. So if I draw a line from this 90 degree angle going to this side, it will take me to the side where 10 meters is. So that is going to be the hypotenuse. Now, in terms of opposite and adjacent, that depends on the working angle. So the working angle that is given here is 30 degrees. Now, if I draw a line from here, going straight across, it will take me to this side. I don't have any information for this side, right? But that side would be opposite because it is opposite to the angle, which means that the side that X meter is going to be the adjacent side because it is one arm of the angle 30 degrees, right? It is alongside it, right? Now, based on the information that I have a length which represents the hypotenuse. I have an unknown side which represents the adjacent, which I want to find, and I have an angle. Therefore, the most suitable ratio is going to be the cosine of an angle. So we can say that by definition, cos theta is equal to the adjacent length divided by the hypotenuse length. Now, we can fill this formula out because we know what theta is in this case. Theta in this case is just 30, so it's going to be cos 30 degrees is going to equal to the adjacent length, which is going to be x in this case, that's the length we want to find, over the hypotenuse length, which is going to be 10. From here, all you need to do is to type cos 30 degrees on your calculator and find what cos 30 degrees is. And that's going to give you approximately 0.866, which is going to equal to x divided by 10. From here, you want to make x the subject. By making x the subject, you will actually find the value of x. How can we make x the subject? We realize that this x is being divided by 10. So we can do the opposite of dividing by 10, which is to multiply both sides by 10. So here we will have 0.866 times 10 is equal to x divided by 10 times 10. Note here, 10 into 10 is 1, so that leaves us back with just x. And 0.866 times 10 will just give us 8.66 meters. All right? And that's how you use the cosine of an angle to determine the length of a right angle triangle. So for our second problem, we are asked to determine the length of P here. So if you notice, the first thing that we're going to do is to label our triangle according to the information that is given. So here, where P is, that is opposite to this 90-degree angle. So that's going to be our hypotenuse. We're given 45 degrees. So we notice that this 5 is adjacent to this 45 degrees because it's beside it. So this side is going to be the adjacent side. That's where 5 meters is. Now, the most suitable ratio here is going to be the cos of an angle. So we know by definition, cos theta is equal to the adjacent length divided by the hypotenuse length. From here, it's all about substitution. What is theta in this case? That was 45. So it's going to be cos of 45 degrees is equal to the adjacent length. What's that? That's just 5 meters in this case. So that's just 5 divided by the hypotenuse length, which is P in this case. That's what we want to find. How do we solve for P from here? We need to put cos 45 on our calculator. And cos 45 will give us 0.707, right? Which is going to equal to 5 divided by P. Here, we want to transpose to make P the subject, right? Now, P is in the denominator, and we know that the subject cannot be in the denominator. So how can we get it into the numerator? We can get it in the numerator by multiplying both sides by P. So we can multiply this side by P, and we can also multiply this side by P. So what we will have is that we will have P times 0.707 is equal to P into P here will give us 1, and P into this P will give us 1, so that will just leave us back with 5. From here now we can solve for P. In order to solve for P, we want P by itself. So note that this P is being multiplied by 0.707. So we can now divide both sides by 0.07, all right? So we're going to divide this side by 0.707 and divide this side by 0.707, okay? By doing that, what will happen is that you can see that 0.07 divided by 0.07 will give us 1, so that will leave us back with P equaling to 5 divided by 0.707. That's going to give us 7.07 meters. And that's how you would complete this problem, okay? So for this problem, again, first thing in term, we want to determine this length, which is B here, right? So if we want to determine what B is, the first thing we need to label our triangle, right? So let's label our triangle. We know if we draw a line from the angle 20 degrees to this side. That will take us to the opposite. All right. So that means we know that longest side is the hypotenuse, and that is always opposite to the 90-degree angle. So where 25 is, that's going to be our hypotenuse, which means that this side where B is, that's going to be the adjacent side. Now, based on the information that we have, we don't have any information for the opposite side. We have information for the adjacent side, the hypotenuse, and an angle. So the most suitable ratio here is going to be the cosine of an angle. So by definition, cos theta is equal to the adjacent length divided by the hypotenuse length, right? Now we can substitute. What is theta in this case? That's just going to be 20. So it's going to be cos of 20 degrees is equal to the adjacent length. What's that? That's just going to be B in this case. It's going to be B divided by the hypotenuse length, which is 25 in this case. At this stage now, we're going to put cos 20 on our calculator. So cos 20 will work out to be approximately 0.94, right? And that's going to equal to B over 25. In order to determine the value of B, all we'll need to do is to multiply both sides by 25. So we're going to take this 0.94 and multiply it by 25, back our equal, and take this B over 25 and multiply it by 25. By multiplying both sides by 25, you can see that 25 into 25 will give us 1. And 1 times B, that will leave us back with B. And 0.94 times 25, that's going to work out to be 23.5. And remember your unit, which is meter. So that's it. Thank you very much for watching, and do enjoy the rest of your day.